Today we are going to be going further with logarithms, and we are going to talk about some very specific properties of logarithms, and then we're going to talk about some laws of logarithms that are helpful in helping you to solve an equation later on. So let's start with the basic properties of logarithms. So there are four basic properties. The first one is that you can't take the log of a negative number. Now you may remember that we did see an example of this last time. I think it was a log of -3. And you'll remember that because if you look at the exponential function, there's no way that the y value ever goes below the x-axis. So there's no way at the same time that you can ever take the log of a negative number, because there's no way for you to get a negative number by raising something to an exponential power. So log of v and ln of v are defined only when v is greater than 0. The second property is that the log of 1 will always be 0. We also saw this last time. We talked about how anytime you have a number raised to the 0 power, it's always equal to 1. And so similarly, the inverse is also going to be true. So the log of 1 will always be equal to 0. So you can write log of 1 is equal to 0, ln of 1 is equal to 0. And this is true of any log, not just common and natural log, but these are the ones that we use the most. So these are the ones that we're writing down. The third property is that the log of its base to a power k is equal to k. Okay, so what does that mean? So if you're looking at common log, if you take log of 10 to a power k, then you know automatically that's going to equal k. But note that it has to be 10 for common log. For natural log, you have ln of e to the k is equal to k. And again, it has to be a base of e there for that to work. So anytime the base of the log is equal to the base of the log that you are taking, then you always know it's equal to the exponent. The fourth property is that the base raised to the log of v is v. Okay, so this one is if you have 10 as your base and you have log in the exponent, then whenever you're taking the log of is what this is equal to. Again, this only works when the base of the log and the base of the exponent are the same. Same with natural log, right? So we have e to the ln of v is equal to v. The base of ln is e. The base of this exponent is e, so it's equal to v. Okay, let's go ahead and apply some of these basic properties to evaluate some expressions. So the first one here, we have 10 to the log of 10,000, and we want to evaluate that. Now you'll notice that we're using common log, which is base 10, and our exponent here has a base of 10. So using the fourth property, we can say that this is simply equal to what you're taking the log of, which is 10,000. Okay, the next one, we have evaluate ln of 1 plus ln of e to the third. So right away we see ln of 1, we should automatically think, okay, log of 1 is always equal to 0. So that's the second property that we apply there. Ln of e to the third. So here, if you look at this, we have ln, which has a base of e, and we're taking ln of something that has a base of e, so e to the third. So since those match up, we know this is simply equal to 3 by the third property. So now this is simply 0 plus 3, which is equal to 3. Okay, so those are the basic properties of logarithms. Now we're going to move on to the laws of logarithms. There are 3 of these: the product law, the quotient law, and the power law. So first we'll start with the product law. So the product law says that if you are taking the log of a product, so log of v times w, then that's equal to log of v plus log of w. Same with ln, so ln of v times w is equal to ln of v plus ln of w. Now the way you actually end up applying these laws will really have to do with the problem. Sometimes you'll want to expand it, sometimes you might want to try to create the product, so you might be going from left to right or from right to left. It really depends on the problem and what you need to simplify. Okay, so looking at example 2, evaluate the expressions by writing it first as a single logarithm. We have log of 100 plus log of 10. So remember that this only works if you have the same base log. So these are both common logs, so we can apply the product law here. This is going to equal log of 100 times 10. And that way now you're only working with one single logarithm, and you're really just finding the log of 1,000. In the log of 1,000, ask yourself 10 to what power will give me 1,000. That's 10 to the third. So log of 1,000 is equal to 3. Okay, look at the second one here. We have ln of e plus ln of e to the fifth. We'll do something similar. So we're going to go ahead and combine it into a single logarithm with natural log. So this is ln of e times e to the fifth. Now that can be combined into e to the sixth. So now you ask yourself, e to what power will give me e to the sixth? And that would be 6. Okay, let's look at example 3. Here you're not evaluating, you're just going to try to expand the logarithm as much as you can. So in the first one we have log of 24x, so this is a product of 24 and x. So we're going to split it up in order to expand it. So now we have log of 24 plus log of x. And that's it. You're just expanding the expression. Second one, we have ln of 7ab. So now we have a product of 3 numbers, 7, a, and b. But this works the same way. So this is equal to ln of 7 plus ln of a plus ln of b. And that is as expanded as it can be. Okay, the next thing we're going to talk about is the quotient law. Now, similar to the product law, where you were looking at the log of a product, now you're looking at the log of a quotient, so one number divided by another. So, log of v divided by w is equal to log of v minus log of w. Same with ln. So ln of v divided by w is equal to ln of v minus ln of w. Now the important thing to remember here that's different from product law, in the product law you can technically rearrange things because you're adding them. It doesn't matter which way you add them. But with the quotient law, it's very important to know that the one that's being subtracted is the one that was in the denominator. So in this case, we have v and w. W is in the denominator. So whatever log of w, wherever that shows up, that should have a minus in front of it. So anything that's in the denominator should end up with a minus in front of it. Okay, so take a look at example 4. We have log of 10 over 1,000. So if we were to expand this, this would be log of 10 minus log of 1,000. And that probably makes it a little bit easier for us to figure this out. Log of 10, 10 to what power gives us 10? That's 1. And log of 1,000, 10 to what power gives me 1,000? That's 3. So this is 1 minus 3, and that's equal to negative 2. Okay, next one we have ln of e squared over e to the fifth. So let's start by writing it in expanded form. So this is ln of e squared minus ln of e to the fifth. Ln of e squared, so e to what power gives you e squared? That's going to be 2. E to what power gives you e to the fifth? That's going to be 5. And then 2 minus 5 is equal to negative 3. So our answer here is negative 3. Okay, example 5. So in example 5, we're not evaluating it. We are just expanding it as much as we can. Now we're going to have to apply both the product and the quotient law here. So if you look at the first one, we have log of 4x over y. So I like to deal with the quotient law first. That way I don't have to deal with a fraction anymore. So if I deal with the quotient law first, we have log of 4x minus log of y. Now we still have a product, right? 4 times x. So we're going to expand this even further. Remember the product law, you're going to add 2 logs together. This is log of 4 plus log of x minus log of y. And that's as expanded as we can get this. All right, let's look at the second one. We have ln of 2x over e to the 4th. So again, I'm going to start with the quotient law. So that's going to be ln of 2x minus ln of e to the 4th. And now we deal with the product law because we still have 2 times x. So we split that into ln of 2 plus ln of x. And then in this case, we can actually simplify ln of e to the 4th, right, using one of our properties. So ln of e to the 4th is equal to 4. So this is ln 2 plus ln of x minus 4. Okay, we have one more law of logarithm to go over. We just went over the product law. We went over the quotient law. The last one is the power law. So the power law says that if you have log of v to the k, that's the same as k times log of v. Same with natural log. So ln of v to the k is equal to k times ln of v. You can think of this as if you have a number in front of the log, you can write it into the exponent. You can think of it as if you have an exponent on what you are taking the log of, you can move it out and put it down in front. Okay, so now let's do some examples where we are going to use all these different laws that we just learned in one problem. So rewrite each of the following expressions in expanded form. So again, I'm going to use the strategy of using the quotient law first, just to get rid of the fraction. So using the quotient law, we have log of a cubed b squared minus log of c. Okay, now I'm going to apply the product law. We have an a cubed times b squared. We're going to split that up. So we have log of a cubed plus log of b squared minus log of c. And the very last thing is we are going to apply the power law. So if you see any exponents, we are going to move them in front of the log. So we have log of a cubed, that becomes 3 log a. Log of b squared becomes 2 log b. And that is your expression in expanded form. All right, let's look at the next one. We have ln of e over the square root of x. Apply the quotient law. We have ln of e minus ln of the square root of x. Now, if you don't want to deal with the square root, we can rewrite this as x to the 1/2. Now that we have x to the 1/2, we can see, well, it's an exponent now, so now we can use the power law and bring that out in front. So we have ln of e minus 1/2 ln of x. Now, if there's anything you can simplify from having expanded this, you can. Ln of e, remember, is equal to 1, right? So e to the first is equal to e. So 1 minus 1/2 ln of x, and that is your expression in expanded form and simplified. Okay, our last example, write the following as a single logarithmic expression. So this time we are going the other way. So it's in expanded form. We want to write this so that it's just ln of one thing. So the first thing I would do is if I see any numbers in front of a logarithm, I would move it into the exponent. So the 4 that's in front of the ln of x, I'm going to move that 4 into the exponent. So we have ln 3x plus ln of x to the 4th minus ln 3xy. Okay, and now if I look at the first two terms here, ln of 3x plus ln of x to the 4th, we notice a plus in between. That means I can write this as a single logarithm of the product of those two, 3x and x to the 4th. So this is going to be ln of 3x times x to the 4th minus ln of 3xy. And now we have two logarithms, so we still need to get it down to one single logarithm, but we see a minus in between, and that means that I can write this as a single logarithm of the quotient of those two. So this is ln of, now 3x times x to the 4th goes in the numerator, and then 3xy goes in the denominator. Now we'll try to simplify everything inside there as much as we can. So up on top, this is 3x to the 5th. And then if there's anything we can cancel, there's a 3 both on top and bottom. And we can cancel out 1x as well. That leaves us with x to the 4th on top and y on the bottom. So ln of x to the 4th over y is our answer.